The correct name for an engine that uses petrol or diesel is an internal combustion engine. Basically, it takes in air through the intake manifold. This air is then mixed with fuel and ignited, and you have your internal combustion, which gives the engine its power. Once the air and fuel has been burnt, the waste gases are expelled out of the exhaust. And that's the basics of an engine and how it works. So let's have a look at the internal components of the engine. Here we have a crosscut through the engine, and you can see it's basically split into two sides. The inlet side, where you'll take in your air mixture, and your exhaust side, which will expel wasted gases. Let's start at the top, and right at the top you have your camshafts. Again, you'll have an intake camshaft and an exhaust camshaft. Here's a photograph of a camshaft, and you can see these are called the camshaft lobes, and they're in an ellipse shape. They're not quite round, and the reason for this is that they can open and close the valves. Okay, the valves sit directly underneath the camshafts, and again you're going to have an intake valve and an exhaust valve, and these control the entrance and exit of gases into the engine. Here we can see in this video we've got our intake cam, our exhaust cam, and as they turn you can see they push down on the valve, and this obviously opens the passage for gases to either enter or exit the engine. Okay, right in the middle here we've got our spark plug, and our spark plug is responsible for igniting petrol in the engine. Now, here's a question: do all engines have spark plugs? The answer is no. Diesel is not as flammable as petrol, and therefore diesel engines use glow plugs. Here's a photograph of a glow plug, and here's the internal components of the glow plug. Inside it has a heating coil. When you switch on the ignition on a diesel vehicle, there should be a dashboard sign that looks like this. This light indicates that the glow plugs are being warmed up. You should not attempt to start the vehicle until this light has switched off. That indicates that the glow plug is now ready, it has been heated, and it will ignite the diesel. Here you can see the glow plug getting hotter and hotter, basically gets white hot, and the light will switch off. Okay, the next component is the piston. Again, here's a photograph of a piston, and the function of the piston is to transfer force from the combustion of fuel and convert it to reciprocating motion. In other words, it will move up and down within the engine. One of the vital components of the piston are the rings. Here you can see the rings quite clearly. At the top you have a compression ring. Its function is to aid in compressing the air-fuel mixture before combustion. Secondly, it ensures that the combustion explosion does not bypass the piston, because this will result in a loss of power. The second ring is your compression or wiper ring. This ring aids in compression as well as wiping excess oil from the cylinder as it moves down. And lastly, we have our oil rings. The oil rings deposit oil onto the cylinder to aid in lubrication as the piston moves up and down within the engine. Our next component, the connecting rod, often just called the con rod. Again, here's a photograph, and it's called the con rod or the connecting rod because it connects the piston to the crankshaft. The crankshaft is found right at the bottom of the engine. Again, here's a photograph of a crankshaft. And the function of the crankshaft is to convert the reciprocating motion of the pistons into a rotary motion. Here you can see as the pistons are moving up and down, the crankshaft is turning in a rotational motion. In other words, the engine is now turning. Okay, let's get back to our cut through. You'll see the green areas are called the water jacket. The water jacket is made of channels that run through the entire engine, and this helps cool the engine down. The 4 strokes. Okay, now that we know what the internal components of the vehicle are, let's look at how it actually works. For internal combustion to occur, the engine goes through 4 stages or strokes. So stroke number 1, the piston is at the top of the engine and it starts to move down. Your inlet valve opens and your air-fuel mixture can now be drawn into the cylinder. As the piston approaches the bottom, the intake valve closes, stopping the air from coming in. The piston has now reached the bottom and has completed the first stroke. The first stroke is called inlet or induction stroke, as your air and fuel mixture have been introduced into the cylinder. For stroke number 2, the piston now will move upwards. And you can see both of your valves, both your inlet and your exhaust valve, are closed. The air and fuel mixture is trapped in the cylinder, and as the piston moves up, it compresses it. The piston continues to move upward until it reaches the top of its cycle. The second stroke is called a compression stroke, obviously, as the air and the fuel mixture have now become compressed. Stroke number 3. Stroke 3 starts with the ignition of the air-fuel mixture, in this case by the spark plug. The valves are still closed. Once the air-fuel mixture starts to burn, the combustion causes the gases to expand rapidly. Basically, it's an explosion. These expanding gases force the piston down. The third stroke is called the combustion or power stroke. And stroke 4, the final stroke. Here you can see the piston is now moving up again. The exhaust valve opens and the burned gases are forced out of the engine by the rising piston. The fourth stroke is called the exhaust stroke. It should be noted that at the end of the stroke 4, the piston is once again at the top of the cylinder in place to start stroke 1. This is why it is called the 4-stroke cycle. The engine works in cycles of the 4 strokes. So, induction, compression, combustion, and exhaust. Induction, compression, combustion, and exhaust. This process obviously is a lot faster than those in the video clips, but how much faster? Well, to see that, we just need to look at our rev counter or tachometer. At the moment, you'll see it's at 0, because the engine is not turning over, it's not running. As soon as we start the engine, the rev counter will rise. The rev counter counts the number of revolutions your crankshaft makes per minute. You need to take note of the conversion figures to calculate your actual revolutions. So 1 is not 1, it's 1 times 1,000 revolutions per minute, or 1,000 RPM. At the moment, the engine is turning over at 800 RPM per minute. When you just press this accelerator, you increase the amount of fuel the engine takes in, and obviously your revs will increase at the same time.